Hi everyone, so welcome back to my channel, and today we are going to see previous year of 12 board exam question papers. So basically I have covered here some integral questions, and we are going to see all those questions. So let us move ahead. So yes, this is the first question that we are going to solve, which is evaluate integration from 0 to pi by 4. Uh, yes, this is the second one. This is the second question that we are going to solve. So let us solve the first one. So integration from 0 to pi by 4, 1 upon 1 plus tan x dx. So first of all, let me explain you that this is a definite integration. We know that there are two types of integrals. First is definite and the second one is indefinite. This is definite. Why it is called definite? Because we can see that here we are having limits, right? So yeah, let us start with the solution. So integration from 0 to pi by 4 dx upon 1 plus tan x. So we have written the question as it is. Okay, so yeah, so we know that tan x is the formula is sin x upon cos x. So tan x we can write down in terms of sin and cos. So basically, yes, we can use this formula and we can write down at the place of tan x sin x upon cos x. All right, so yeah, this will become sin x upon cos x. Now in the next step, what we are going to do is we will write down the same integration from 0 to pi by 4 dx. And then if I take the LCM in the denominator, clearly the cos x will come in the numerator. So cos x I have written in the numerator, and then after taking the LCM, this will become cos x plus sin x. All right. And then we have dx as well. Now after this, what I'm going to do is I am going to multiply and divide by 2. So here I have divided by 2. So to just balance it out, I'll multiply also by 2. So yeah, so now in the next step I'll write down half integration from 0 to pi by 4, and in the place of 2 cos x I can write down 2 cos x as cos x plus cos x, right? And then upon cos x plus sin x as it is, and then dx. Alright, let us move ahead. So now we can write down this as half integration from 0 to pi by 4. So in the numerator, what I'm going to do is, as you can see, we are already having cos x plus cos x. So I'll write down that cos x plus cos x as it is. But here I'm going to add sin x and subtract sin x again, just to balance it out, because I'm adding something. So just to balance this, we know that we have to subtract the same thing. So I have added sin x, and at the same time I will subtract also. Alright, so sin x plus cos x, and then minus sin x upon cos x plus sin x that we were having in the denominator, we are writing as it is, and then of course dx. Now let us move ahead. So here what we are going to do is we are separating the LCM. So half integration from 0 to pi by 4, and then I'll write down sin x plus cos x. Okay, first, and then upon cos x plus sin x I have separated the LCM, and then okay, so basically in the numerator what I'm doing is I'm just writing minus and then writing everything inside the bracket. So sin x, and of course we have plus cos x, but because I'm writing in the in bracket and we are having minus sign in outside, so that is why plus cos x will become minus cos x, that and then upon cos x plus sin x dx. Alright, so let us separate this in the next step. So half integration from 0 to pi by 4, and then we can write down this as sin x plus cos x upon cos x plus sin x, which is same as sin x plus cos x only. Alright, so this is nothing but the separation of the the LCM, and then minus sin x minus cos x upon cos x plus sin x dx, of course. Alright, so yeah, Now let us move ahead. So here you can see one thing that sin x plus cos x and cos x plus sin x, they are the same things. So of course we can cancel it out. We know that if we are having the same term in the numerator and same term in the denominator, that will be equal to 1. So here you have to notice one thing, that just do not write down, because you cancel sin x plus cos x upon cos x plus sin x. So do not forget it to write down, because that value is basically 1, right? So just do not forget to write it down. So yeah, in the exam, this is one of the most important points. So yeah, 1 minus and then sin x minus cos x, writing the same thing as it is, upon cos x plus sin x dx. All right, and now we can move ahead. And now there is one property of integration that we are going to use here, is that we know that we can distribute, we can use the property of distribution in integration. So yeah, so half and then integration 0 to pi by 4 and then 1 of course, and then dx minus, of course that half will come again, half integration from 0 to pi by 4 and then sin x minus cos x upon cos x plus sin x. All right, now let us move ahead to our next step. So basically we all know that what is integration of 1, right? Integration of 1 is x, because we are doing with respect to dx. So yeah, half, and then integration of this will become, directly we can write down x, and of course we have to write down the limit, which is going from 0 to pi by 4. Now minus half, and I have forgotten to write down the limits, so yes, please write down the limits, 0 to pi by 4. All right, in the above step. All right, so here what I'm going to do is I'm going to use a formula, and the formula is, if we have integration of a function that is present in the denominator, and if we are having the derivative of the same function which is present in the denominator, if we are having the derivative of that function in the numerator, that will be equal to log of the denominator, whatever function we are having in the denominator, plus the constant of integration, of course. But here we are not going to use the constant of integration, because this is a definite integration, and in definite integration we do not add plus constant of integration, remember that. All right, let us move ahead. So half, and then we have we can use the formula basically, because you can see here that we have a function cos x in the denominator, and if you just find the derivative of this function, you will be getting sin x minus cos x, because the derivative of cos x is sin x and derivative of sin x is minus cos x. All right, so as we have the derivative present in the numerator, so we can use this formula and we can write down log of the function, and the function is cos x plus sin x. All right, and of course we have our limit, so we will write down the limit as well, which is from 0 to pi by 4. All right, so let us write down a bracket and then write down the limits 0 to pi by 4. Now we are towards the end only, so we just need to substitute the limits. So half, and the formula is, we have to first put the upper limit minus the lower limit. So here the upper limit is pi by 4 minus the lower limit, that means x will be 0. So pi by 4 minus 0, minus half, and then here also we are going to put the value of limit, so log, and then mod, we have here cos, we will first put the upper limit, which is pi by 4, so cos pi by 4 plus sin pi by 4. All right, and then mod sin closed. Okay, and then we have minus log and cos 0 plus sin 0. Okay, we have put the lower limit as well, and then bracket closed. Now here we can write down this as, of course, half into pi by 4 will become pi by 8, because 1 into pi is pi and 2 multiplied by 4 is 8. So pi by 8 minus half, and then we can solve this basically, because we can just write down log, and then we know the value of cos pi by 4, that is 1 upon root 2, correct? Similarly, we also know the value of sin pi by 4, which is 1 upon root 2. Okay, so if you just add 1 upon root 2 plus 1 upon root 2, that will become 2 upon root 2. minus log. The value of cos 0 we all know is 1 and sin 0 is 0. So 1 plus 0 is 1. So that is why we are getting log 1. And now we can write down the final step almost. So pi by 8 minus half, and this is log 2 upon root 2. So basically we can see that we are having an irrational number in the denominator. So what we can do is we will just rationalize this somewhere else. Let us rationalize and write down the final answer. So 2 upon root 2 we need to rationalize, so we just need to multiply and divide by the same number. So into root 2 upon root 2, and that will become 2 root 2 upon root 2 into root 2 is 2. So that 2 and 2 will get cancelled, so we will just get root 2. So log root 2 minus, we know that the value of log 1 is 0. Alright. So here we can directly put the value of log 1, which is 0. So that will become minus 0. Alright. So the next step will be, yes, this is the final answer basically. So pi by 8 minus half log root 2. So I hope you have understood this solution. So now let us move to the next question. So here we need to find integration of e raised to x sine 2x dx. All right. So basically here you can see that we are having a product of two functions, right? So basically here we are going to use a formula. So let me explain you about the formula. Okay, so basically this is, we have like integration of a uv function. Okay, so suppose I'm putting the first function as uv and second function as v. Okay, so the formula says that we have to first write down the first function as it is, and then integration of the second function minus integration of the first integration of the derivative of the first function, and then into integration of the second function. All right, so this is the formula that we are going to use. All right, so let us move to our question. So here also we need to decide which one is the first function and which one is the second function. So that we are going to decide on one rule that is called I late. All right, so here I stands for inverse of inverse function, inverse trigonometric function. L is for logarithm, A is for algebraic, and T is for trigonometric, and E is for exponential. So here this is the order, so you just need to give the preference from left to right. All right, so here in our question you can see that we have an exponential function and we have a trigonometric function. So of course the first preference will be given to the trigonometric function, which is sine 2x. So let us just write down sine 2x as the first function and the exponential function as the second function. So basically here sine 2x is playing the role of u and e raised to x is playing the role of v. All right, so yes, I have written the same question as it is, integration e raised to x sine 2x. This is the first function, trigonometric function, and the second one is exponential. How I decided? I decided using this I late. All right, remember this rule. Okay, so we will now move ahead. So now we can use a formula, as you can see here. Okay, we can just write down this function as I. Let I is equal to this function, and now we need to find the value of I. So I is equal to, using this formula we have to keep the first function as it is. So sine 2x we will write down as it is, okay, using the formula. So let us write down sine 2x as it is, because we have considered that function as the first function. All right, so sine 2x as it is, and then using the formula integration of the second function. But here integration of e raised to x, we know that integration of exponential function is same as it is, so let us not write down that and directly write down e raised to x. So that will become multiplied by e raised to x minus, using the formula, integration of derivative of the first function. So derivative of sine theta we all know is cos theta, right? So here derivative of sine 2x will become cos 2x, and of course we are going to use the chain rule, so we will do the derivative of 2x as well. Derivative of 2x will be 2. And then using the formula again, we have to write down the integration sign, and now we will write down the second function, which is e raised to x. So let us write down as it is, and then we have dx. Now we'll move ahead. So I is equal to sine 2x into e raised to x as it is, and then here we can write down this as, I can write down this 2 outside of the integration. So this will become 2 integration of cos 2x, and then integration of e raised to x we all know is again the same exponential function. So this will become e raised to x dx. All right. Okay, now let us move to the next step. So this will become I is equal to, so here basically you can see one thing that I have written integration cos 2x into e raised to x. Again, I am getting a product of two functions. So here again I need to use a formula. So again I have decided using ILATE that cos 2x will be considered, will be given the priority. We will give the priority to cos 2x because that is a trigonometric function. So that will become first function and exponential is the second one. Now repeating the same step. So I is equal to sine 2x into e raised to x minus twice of, using the same formula as you can see, integration of uv. So keeping the first function as it is and doing the integration of the second function, that will become e raised to x minus integration of the derivative of the first function. We know that cos theta derivative is minus sine theta. So minus minus will become plus, and sine 2x will become, and cos 2x derivative is sine 2x. And now by chain rule, the derivative of 2x will become 2. So I have multiplied 2 and I have written that 2 outside the integration sign. And then we have integration of e raised to x, that will become just e raised to x, correct? And then dx. Now we can just solve this. So I have written I is equal to sine 2x into e raised to x minus twice of, let us write on the same thing, cos 2x plus cos 2x multiplied by e raised to x plus twice of, here you can notice one thing, that I am having this integration of sine 2x into e raised to x dx in my first step, correct? And that is equal to nothing but I have already taken this before. So instead of writing integration of e raised to x sine 2x dx, or integration of sine 2x into e raised to x, both are same thing, I can just substitute the value of I. So I can just write down this as 2i. All right, now it is looking very simple. So we can just write down this as I is equal to sine 2x into e raised to x, and then we have minus, we will just multiply this, so twice of cos 2x into e raised to x, and then minus plus minus, so 2 into 2 is 4i. Now we can just shift this minus 4i to the other side, so this will become I plus 4i, and then here we can just take e raised to x common, of course. So if I just take e raised to x common, so let us do that in the next step. So sine 2x into e raised to x minus twice of cos 2x into e raised to x, and I plus 4i is 5i. So this is 5i, and then here we can take e raised to x commons because we are getting e raised to x in both the terms. So if I take that e raised to x common, so I'll be getting inside the bracket just sine 2x minus 2 cos 2x, right? And since we wanted to find the value of I, so I'll just keep I as it is, but I'll shift this 5 to the other side. All right, so if I just shift 5 to the other side, so that we can write down as, okay, here I forgot to write down the constant of integration because definitely we can see that this is not a definite integration, this is an indefinite integration. So of course you need to use the constant of integration, and then writing the same step by just shifting 5 to the other side, the final answer we are getting is 1 upon 5 multiplied by e raised to x into sine 2x minus twice of cos 2x plus c. And that is the final answer. And remember that these two questions have come so many times in the board exam, in 12th board exams. So if you do not know how to solve these two questions, please understand this. And if you like the video, then please Do not forget to subscribe to my channel. All right. Thank you.